I'm here with Camilla, and Camilla's here to help us explore the angles of polygons. It's fun to look for polygons all around us. They're easy to find. In this video, we will learn to apply the polygon angle sum theorem. We will also learn how to apply the exterior angle theorem for polygons. How about that little triangle right there? To start us off, what's a polygon that most people over the age of 16 take a moment to stop and look at least once every day? And here we are exploring the angles of polygons. Now here's a polygon. It's a polygon that resembles a very famous building in Washington, D.C. In fact, the name of that building is shaped like this polygon. And I bet you already know that this is a five-sided polygon, 1, 2, 3, 4, 5, which is a pentagon. When we're talking about the interior angles and even exterior angles of polygons, we're working with convex polygons. So we can leave stars out of this equation, but we're going to find the sum of interior angles of a convex pentagon. Well, that is a very simple formula. Here it is. It's a very simple formula and it works for any convex polygon. It doesn't have to be a regular polygon, but any pentagon. The sum of the interior angles of a pentagon is n minus 2 times 180. N is the number of sides. So let's do 5 minus 2 times 180 degrees. Now I know from experience, because every convex pentagon has this magic formula, that 3 times 180 is 540 degrees. So look at this. We have a regular convex pentagon with all angles and sides are congruent. And we said that the sum of the interior angles is 540 degrees. Well, the angle sum theorem for polygons states that as long as it's a convex polygon, this formula works. That's the n minus 2 times 180. And we can say that the sum of the interior angles for this polygon as well equals 540 degrees. The sum of the interior angles is the same for both. However, sometimes we can say what is the measure of each angle inside a regular convex pentagon. Because they are all equal and they add up to 540, can't we find the measure of each one? And so look at this. For a regular convex pentagon, the sum of the measures is 540, and each angle, all we have to do is divide by the number of sides, which is also the number of interior angles, and that is 540 divided by 5, and each angle measures 108 degrees, 108, 108, all the way around, and that's a very useful number that won't change no matter how large the regular pentagon is. Now let's come on down here. If each angle is different and the sum of the angles is 540, we know that. That won't change. Can we find each angle just by what we're given here? We cannot. So we know that the sum of the interior angles of any convex pentagon is 540 degrees. But when it's an irregular, as this one is, we have to be given terms that represent what is each angle in terms of x, or a variable. So now we can get each angle, and you can see they're all different. A couple of them are the same measure, but this is not drawn to scale. So we're just going to use a mathematical minds to figure out how much do all of these need to add up to. Here comes a little bit of algebra fun. Well, I'm just going to start at one vertex and make my way around so that I can make sure I get every single angle. And what should they add up to? 3x plus 4x plus 3x plus x and plus 4x. It's a pentagon. How many angles? 1, 2, 3, 4, 5. And all of that adds up to the magic number 540. Now all we do is the algebra and the math. Combine like terms, solve for x, and make sure you plug it in. So here we go. 7, 10, 11, 15. 15x equals 540 degrees. Now all we do is divide by 15, and we get x equals, what is 540 divided by 15? I'm going to use my calculator because I don't want to waste too much time. And I'm going to say 36 is x. X is 36. Now, we're almost there. All we have to do is plug that x into every angle and find out what each angle is. So let's take a look at this triangle. Now, a triangle, is it a polygon? You bet it is. It's a three-sided polygon. And this one is a convex polygon. Now, we're going to study the exterior angles theorem, and we were given some exterior angles, and we'll talk about that in a minute. But I just want you to remember a theorem from a long time ago, and it relates to the polygon angle sum theorem. It's a great way to remember it. We know by the triangle sum theorem that what do all of the interior angles of a triangle add up to? We know that because I know you're all yelling it out right now, 180 degrees. So the sum of interior for a triangle, the sum of the interior angles is 180 degrees. That's the triangle sum theorem. Well, you could still plug it into that formula for the polygon angle sum theorem, and that's just n minus 2 times 180. How many sides to a triangle? 3 minus 2 times 180. Look at that. 1 times 180 is 180 degrees. So this polygon angle sum theorem works as well as the triangle sum theorem. So that's just the interior angles for any convex polygon, and that worked for the triangle. But now we are extending these lines and we're finding one exterior angle at each vertex. When we do that, we've got a great number. Look at that. That's what we did here. One angle, one angle, one angle. It's a triangle, three sides, three exterior angles. 152 plus 63 plus 45. They did the math for you. It's 360 degrees. let's look at this one. This is a fun one because we have a 1, 2, 3, 4, four-sided polygon. That's a quadrilateral. Now, a quadrilateral, we could find out what the sum of the interior angles of a quadrilateral is, n minus 2 times 180. But we're not looking for that now. We're looking for the sum of the exterior angles, which we know, what is the sum of the exterior angles of any convex polygon? 360 degrees. That's the sum of, and I'm just going to abbreviate, exterior angles. Well, if we know that the sum of the exterior angles is 360 and there's 1 at every vertex, which means there's 4, we are going to add each of those terms and they should all add up to, got it, 360. So let's do it. Ready? I'm going to start and just go clockwise. 4x minus 18 plus, I'm going to drop the parentheses because I'm adding. That's a good trick. Drop those parentheses. 2x plus 2 plus 2x plus 3x plus 2, and that all equals, I ran out of space on that long line, 360, but I'm going to get some space back because I'm going to combine like terms. When I combine like terms, I'm a little extra careful and I underline things that are similar terms. So I'm going to start with x's. 4, 5, 6, 7, 8, 9, 10, 11. 11x 4, 5, 6, 7, 8, 9, 10, 11. Check to myself. And, negative 18 plus 2 plus 2. That's a negative 18. So we're going to actually subtract, and we're going to end with a negative 18, 17, 16, 15, 14. 11x minus 14 equals 360 degrees. Good enough so far. Add 14. 11x equals 374. Do I know that off the top of my head? I'm going to use a calculator. I went off to the side and used my calculator, and can you believe it? X is a whole number, 34. Now, if I asked for X, you would be done. If I asked you to plug X in and get every exterior angle, you could do that. And if I asked you what do all of those exterior angles add up to? 360 degrees. Always for convex polygons. Magic number, 360. Three last problems, easy but worth mentioning. Here we are. We want the sum of the interior angles of a convex 20-sided polygon. Here we go. 20. So it's n minus 2 times 180. I'm just going to do 20 minus 2 times 180. And what does that equal? 18 times 180. I'm so glad I brought my calculator today because I know that that answer is 3,240 degrees. It's a lot. That's how much all of the angles add up to the interior angles of a 20-sided polygon. Now let's do the measure of each angle in a regular convex 15-sided polygon. Each angle should be a regular polygon. It is. Okay, each angle 15, so I'm going to do the sum of the angles, which is 15 minus 2 times 180, and that's 13 times 180, and so the total angles, and you can just keep on punching on in your calculator, but I just want to show you the total angles. It adds up to 240 or 2,340 degrees. And what are we going to do if we want each angle and we know it's a regular and they all add up, or they're all equal? 2340 divided by, how many are there? 15. What is that? That's 156 degrees. Now take a look at this one because it's pretty easy, but you gotta read and think. Measure of each exterior angle of a regular octagon. Octagon, 8-sided polygon, 8 sides, n equals 8. Now, we know that the sum of exterior angles is that magic number, 360. But if they wanted each one of the exterior angles on an 8-sided polygon with 8 exterior angles, 1 at each vertex, that becomes 360 divided by 8. It's pretty easy. 360 divided by 8 is 45 degrees. Here's a hint on the answer to that riddle.
Stop in the name of love before you break my heart. Think it all over.
Thanks for helping, Camilla. And thanks for helping, Misha. And thanks for watching.